Hello, 7.34 is basically the HL translation. So I know we spoke about this already in core, in the SL stuff, and the standard level stuff, but we're going to add a couple more parts to it. So when we talk about translation, we are going to talk about start codons, stop codons. We're going to talk about the 4 steps in translation, and we're also going to talk about the ribosome itself. In a different video, we will talk about polysomes, but we'll talk about that later. So one of the 4 steps of translation is a stage called initiation, which means to start. So we're starting translation. And before we even have, oh my goodness, I'm having trouble drawing. Before we even have this whole complex with this ribosome that we're used to seeing with a large subunit and a small subunit, it's not like that. It's disassembled. So we have a small subunit just floating around in the cytoplasm, and a strand of messenger RNA will bind to the small subunit. And actually, there's a little binding site, which they identified as this dark spot. There's a little binding site on the small subunit for the ribosome, for the messenger RNA to bind. So this small subunit is actually going to start working its way from the 5' to the 3' direction, because that's how everything works in genetics. So the ribosome is moving this way, so you can think of it as the messenger RNA moving this way. And as soon as the start codon, one of the codons that you need to remember, there are a few. Sometimes students ask me, hey, do I need to know all the codons? No, but there are a few that would help you when you're answering a longer response question, paper 2, section B. So when that start codon is located at the P site, well, there isn't really a P site yet because a large subunit isn't there. When that's kind of in the middle of our small subunit, boom, transfer RNA will form complementary base pairs with that codon with transfer RNA's anticodon. You get points for that. So if you say transfer RNA, complementary base pairs to the start codon AUG with its anticodon UAC. That's a good way to get points. And it brings over the very first amino acid, methionine. Every single polypeptide starts with that amino acid. So that is initiation. Oh, I skipped the when the large subunit comes on. So once that's there, Kaplawi, the large subunit will end up on top of this small subunit, but not until we have our very first transfer RNA molecule coming in with that first amino acid. All right, let's talk about step 2. Actually, step 2 and 3 I have on the same page. So step 2 in translation is called elongation, which means to get longer. And the thing that's getting longer is our polypeptide. So we're going to keep adding amino acids on and on and on until we get a long chain of amino acids to form a polypeptide. So how this works, if we're using this diagram here, how this works is when that large subunit comes on, we have that A site exposed. Our very first transfer RNA, our second transfer RNA molecule will come in, bind to that A site, complementary base pairing, and those 2 amino acids will form bonds in amino acids are called peptide bonds, form a peptide bond, and now we went from 1 amino acid to 2. We got longer, right? The polypeptide got longer. So that's what elongation means. Then, as this ribosome continues to move down, we use a term for that. And that term is translocation. So it moves down again. This first transfer RNA who attached its amino acid to the second one, doesn't have an amino acid anymore. It moves to the E site and bye-bye, sent back into the cytoplasm to be reconnected with its amino acid again. And its amino acid will be methionine because that's the one it lost. So that's what translocation means. And we just keep doing this process and this process and this process, and these amino acids will keep attaching. I know I'm drawing them on the top, but I want you to think of that they're being drawn or connected on the bottom. So methionine is still at the top here, but it keeps getting longer and longer and longer until termination. So termination is just a fancy word for the end, and that's what it is the end of translation. So what happens with termination is that we reach one of the 3 stop codons on our messenger RNA. So here's our messenger RNA, and it might be a little hard to see here, but those 3 letters say UGA. That is one of the 3 stop codons. There is not a molecule of tRNA that has an anticodon that will complementary base pair to that. Actually, all 3 of these. There doesn't exist, or a molecule of tRNA doesn't exist. Instead, this protein called a release factor comes into the A site. And when it does that, 2 things happen. Our finished polypeptide is released to go start its career as a protein somewhere, whether it's an enzyme or a hormone or whatever it else has planned. And the second thing that happens is this whole complex is disassembled. The large subunit disconnects, the small subunit disconnects, and this messenger RNA is recycled. There is an enzyme that actually just cuts these nucleotides up into individual pieces. All the A's and the U's and the C's and the G's get cut up, and they will eventually return to the nucleus so they can be used again for transcription.